Good afternoon, everyone. Okay, today we're going to take a look at making a velocity graph from a position graph. Okay, step one is just stop it. Don't even look at it yet. Think about what you're about to look at. Okay, don't think about, oh, this line always means this, because you always like, well, if it goes up, it means this, but then you're looking at the wrong graph. Okay, so we're looking at a position graph. So it tells you where is the object, okay, and how does that position change. So what we're usually looking at here, the big thing is velocity on a position graph is the slope, okay? Velocity is change in position per change in time, which is the same thing as our slope on our position graph, okay? So we're gonna take a look here at this first one. First things first, okay, it looks like we start at a -4 meters position. We move forward at a constant rate, okay? How do I know it's constant? If your slope's a straight line, okay, it's constant velocity. Okay, constant velocity. Because that slope's not changing, and then our velocity is not changing because our velocity is our slope. So constant velocity forward, the position stays the same here, and so our velocity is 0. It's stationary, it's not moving, and then it moves backwards. So our velocity is negative. Okay, so I'm just gonna put that there. I know my velocity is positive, I know my velocity is 0, and I know my velocity is negative here. Okay, let's just do this. Velocity is negative. Okay, so in order to graph this, we have to take a look at what our slope actually is. Okay, and to find slope, you just use your slope equation. M equals your y2 or yf, your final minus your initial, over your final x minus your initial x. Okay, so here our velocity is equal to our final velocity minus our initial velocity, would be over our final time minus our initial time. Okay, so we start off here at 0 and -4. We go then to 2, 1, 4, 1, okay, and 6, -1 down here. Okay, so for our first 2 seconds, okay, we can do it. So we end at 1 meter. We started at -4 meters, so we're going to subtract a negative, which ends up being a +4, right? Over 2 seconds minus 0 seconds, okay? So we've got 1 plus 4 is 5 meters over 2 seconds, gives us 2.5 meters per second, okay? It's constant velocity. So we know at time 0, that's how fast we're moving, so I'm going to put a dot here. 2.5 seconds later, I'm still going at that velocity because it's constant. Okay, so that's going to be right around there. Okay, somewhere in there. Okay, it's constant. It's going to be a horizontal line. Oof. Man, I'm sorry. Let's see here. Straight line. Okay, ish. Get a ruler out. It doesn't really work on the computer screen. I'll try it next time. Okay, and then we know it's a horizontal line, so our position is not changing. Okay, so if it's not changing, we're not moving. If we're not moving, our velocity is 0. Okay, so that's from, that's from 2 seconds, just after 2 seconds to 4 seconds. Okay, and we're going to try this ruler this time. Let's see what works in here. Yeah, we're going to start hitting all kinds of things. There we go. Okay, and then we can go ahead and connect that. Okay, it's not going to quite be vertical. No. Oh, stop. Right there. It's not going to quite be vertical because you can only be one velocity at a time, right? Okay, but it's going to be a quick stop. Okay, and then we're going to go with a negative velocity, and we can go ahead and figure out what that is. Again, you end at -1 meters. You're going to subtract 1 meter from that. Okay, you end at 6 seconds. And you're starting that section of motion at 4 seconds. So it's going to be -2 meters over 2 seconds, gives us -1 meters per second. Okay, and this area is from 4 seconds to 6 seconds. So at 4 seconds, just after we're done stopping, we're going to be moving at -1 meters per second. Put that there. And at 6 seconds, we're still going at -1 meters per second. Again, the constant straight line. It's a constant velocity. Boom, here, and then not quite vertical. Okay. Where's the velocity? See, we start out going forward at constant velocity, forward or a positive constant slope, 0 slope, constantly stopped on our velocity graph. Then we're at negative constant velocity here, negatively moving backwards here. Okay. Take a look at one more example then. Okay. We're going to do the same thing here. We start off, just take a look, okay? Negative constant velocity, a different negative constant velocity here, and then we end up with a positive constant velocity. Okay? So we know that these first two are below the x-axis, okay, because the negative velocity is below the x-axis, and then the positive is above, okay? Positive velocity is above. So we know that much. So we kind of know what our graph's going to look like, okay? We're going to take a look and see what our points are. We're going to start off at 0, 5. We're going to go to 2, 1. We're going to go to then 6, negative 1. And we're going to finish up at 7, 0. So for this first segment of constant velocity, we end at 1 meter, and we start at 5 meters over 2 seconds minus 0 seconds gives us negative 4 meters over 2 seconds, so negative 2 meters per second. So from time 0 to time 2, we are moving at a constant negative 2 meters per second. So we can go ahead and draw that line there. The second set of constant velocity is also negative, okay, but it's slower because it's downward sloping. We end at negative 1 meter. We started at 1 meter over. We ended at 6 seconds. We started at 2 seconds. That gives us negative 2 meters over 4 seconds. So we have slowed down to now a negative 0.5, or 1/2. It's negative 1/2 meters per second, or negative 0.5 meters per second. And so right after 2 seconds, again, not quite vertical. We can only go one velocity at a time. We do that until 6 seconds. Okay, so we're going to go ahead. Why does it keep doing this? Put a dot there. Go ahead and make another straight line because our velocity is not changing. Boom. Okay. That should be a straight, just not quite vertical like always. Okay. And then we start moving forward. So we know we're going to be above the x-axis there. We end up at position of 0 meters minus a negative 1 meter. Okay. Over 7 seconds minus 6 seconds. Okay. So we're going to add that negative, or we're going to add that 1 because minusing a negative is adding. So we're at 1 meter per 1 second, gives us 1 meter per second. And we're going to do that from 6 to 7. So we're at 1 just after that for 1 second. Straight line, so it's at constant velocity. And then go ahead and connect those two. Okay. Not a quite vertical line, right? So we start off moving backwards at a relatively steep velocity, or steep slope, so it's a lower velocity here, straight line. We slow down to a different constant velocity. We have a smaller, or technically bigger because it's less negative. It's a slower speed, so it's closer to 0. Straight line, and then we go forward, so it's above the x-axis. Okay? Now we're not going to worry about drawing velocity graphs with changing velocity and constantly accelerating velocities because it gets a little more complicated. So hopefully this was helpful. As always, everyone, good luck, have fun, and take it easy.